All right, so for this one, now first of all, if you can do partial fractions in an exam in less steps, then you can skip steps doing this. A lot of the time the examiner knows that you can actually do it. There's actually another method which I'll show you another time, and that is like a shortcut method for doing partial fractions. You can do it without really doing any algebra at all. I won't do that today though, because I want to show you the long way to make sure we're not making any mistakes. So, first of all, what we've got to do is forget about this integral. I don't not want you to worry about that for the time being. We're just going to deal with what's inside that, and we're going to express that as a partial fraction. The first question we ask, thank you, is what is the order of the numerator? The order of the numerator, in terms of it's a polynomial numerator. It's a polynomial of degree 1. The denominator is a polynomial of degree 2, which is factorised. And that is a big sign that it's a partial fractions, because if the numerator and the denominator are of the same degree, then you'll have to apply polynomial division. Or if the numerator was degree 3 and the denominator was degree 2, then that would also be, that's the denominator. Denominator. All right, it's the denominator. I can spell, I swear. It's just late in the day. It's not the denominator. All right, now, what we're going to do then is, this is how I would set it out, and I would do it in the top right-hand corner of the question, very small, and then I can then later on use it. I would say that 3x plus 5, we need to express this. We need to express this expression as a. We want to find a over x plus 1 plus b over x plus 5. Now, I want to get like denominator on both sides, so that means I'm going to sort of skip a step. It should be fairly obvious that I've got to multiply a by x plus 5 and b by x plus 1 to do that. Thanks, mate. All right, so what we're going to do now is I want to solve for a and b. So I'm going to let x is equal to negative 5, and therefore that's going to give me 3 times negative 5 is negative 15 plus 5 is going to be equal to, what is that, negative 4b, is that right? I hope so. So we've got negative 10 is equal to negative 4b, which is going to imply that b is equal to 10 over 4 or 5 over 2. Okay, so we've found b. Now what we've got to do is we've got to find a, and in order to do that, we're going to let x equal something nice like negative 1, because then that's going to cancel that out, isn't it? So we're going to say that minus 3 plus 5 is equal to 4a. And I've got that 2 is equal to 4a, which implies that a is equal to a half. Yes! Now, I'm just going to replace. So what I would say is, once I've worked out my partial fractions on the top right-hand corner, if I was doing this in an exam, I would say that therefore the antiderivative of 3x plus 5, if you guys want to show working properly, this is what you say, is therefore equal to 1 over 2. I'm going to do this as well. And I'm also going to split up it into two integrals. Plus, 5 over 2. What is it? Log x plus 5. All right. Dx. Now, I'm going to then finish that off, aren't I? So if I'm antiderivative, and the reason why I've put those out the front, those constants out the front, is because it just makes it very obvious. The derivative of x is 1. So therefore, my answer is going to be a half log e to the, be careful, x plus 1. Plus 5 over 2 log to the base e of x plus 5. And of course, plus c would be an antiderivative. Are we okay with that? Is that what we got? Good. All right, I'm just going to pause this and do a bit of... Okay, so for this one, the polynomial on the numerator is of equal value or greater. So I'm going to do some polynomial division. X squared goes into x squared once, and then I'm going to multiply it back out. X squared, and be careful, minus 4 goes over here. So I'm going to put a little 0x there just to make sure. What am I doing then? I'm subtracting them. Minus 6 minus 4 is what? Negative 2, thank you. Now, what do I do now?
5x minus 0.
Okay. 5x minus 0 is 5x, thank you. Don't forget that. Awesome. Now, what do we do now? Can we do anything more? No. We know that x squared minus 4 is not going to go into that. So this is what it's called our remainder, isn't it? So what we've got is if I've got x squared plus 5x minus 6 divided by x squared minus 4, it goes in one time with the remainder. So therefore what we're going to say is that x squared plus 5x minus 6 over x squared minus 4. It seems really tedious, but you have to use equal signs. That is equal to 1 plus, what have I got next? What's that? Yeah, I did. 1 plus 5x minus 2 over x squared minus 4. Thank you. Now be careful. I actually have to do partial fractions now, don't I? Do I have to do partial fractions now? Yes, I do. Shh. So, let's do some... This is getting a bit messy now because it's not that easy doing it on this thing, but I'm going to do partial fractions for this. Well, let's first of all just say that 5x minus 2 over x minus 2, x plus 2 is equal to a on x minus 2 plus b on x plus 2. Is that right? Yep. Now, what did you find? We've just done one of those. So what did you find for A and B? What did you get for A and B? A is equal to 3. B is equal to 2. All right, thank you. Shh. Definitely tell it's the last period of the day. Now, what we got, therefore, is that is equal to the antiderivative of 1. Well, that's pretty straightforward. We want to do the antiderivative of... So we're going to just say that that is x. Is that right? Awesome. Plus the antiderivative of... I might just keep it in there. 3 over x minus 2 plus 2 over x plus 2 dx, which is equal to, well, I'm going to go ahead and do that. Well, I can do that straight away. I can say that that is x plus 3 log to the base e of x minus 2 plus 2 log to the base e of x plus 2. Can I do anything else?
Oh, wait, no. Actually, yeah, the 2 and the 3 are the other.
Oh, okay.
I did my 8.
All right. So that's 2. And that's 3, is that right?
Yep.
Okay, good. Now, is there anything else I could do for you?
You can simplify the logs.
What's that?
Simplify the logs.
Yeah, okay. So what I'm going to do is if I want to do some simplifying, I can say that that's x plus log to the base e of x minus 2 all squared. If I'm going to square that, do I need the absolute value sign? No, I don't. And plus log to the base e of x plus 2 all cubed. You do, thank you. You do need the absolute value sign because it's cubed. Thank you. Is there anything else I can do? We can smush them together. Okay, so you're telling me what? x minus 2 squared times what? The absolute value of x plus 2 all cubed. Yeah, okay, why not?
Or you can make that whole thing into an absolute value.
Yes. Very good, Jahom. If you wanted to. All right. So that's that one. Now we've got to do, I'm going to just pause for a second, do some cleaning up, so then we can go through example 3. Resume now. All right, so this third example is a case where we have repeated factors. So this time we've got to first of all consider the 2x plus 6 on x minus 1 all squared is equal to x minus 1 all squared is one factor, and we have a second factor of x minus 1. We therefore have A and B, and you guys should know this from Gen A, but I know it's a while away. So you've got, this is, I guess, a common mistake that a lot of students make is realising that there's actually two factors. So what we're going to do is we've got 2x plus 6 is equal to A times x minus 1 plus B outside of What am I doing? I'm going to resume. All right, so I've got this. I don't have to multiply A by anything. So I'm going to let x is equal to 1. And when I do that, I'm going to have a left-hand side of 8 is equal to A plus B times 0. So A is going to be 8. And then in the second case, I might just, since I know that A is 8, I'm just going to let x be something nice and simple, like 0. And that's going to give me a left-hand side of 6 is equal to 8, which is A, we've just found that, minus B. I'm going to then add B to both sides. We've got B is equal to 2. So we now have this as A is equal to 8, x minus 1 all squared, plus B, which is equal to 2, over x minus 1. All right, so if we're finding the antiderivative of that, we can say that we've got that this, we now have this integral here, plus 2 over x minus 1 dx. All right, so now what we need to do is anti-differentiate that. And I'm just going to finish that off just quickly now. All right, so I've worked that out, had my little moment there, and I'm going to then sub in my values. So what we've got is we've got minus 8 over 3 minus 1 is 2, plus 3 minus 1 is 2, 2 log to the base e of 2. I'm then going to subtract minus 8 over 1 plus 2 log to the base e of 1 is just going to be 0. Log to the base e of 2 minus 1. And I'm going to finish that off is minus 4 plus log e to the, I'm going to bring this inside, which is log base e of 4, and then I'm going to have minus, sorry, I'm going to have plus 8, and this becomes 0. So we've got, should have an answer of 4 plus log to the base e of 4. And last but not least, we've got the final case. We think this is partial fractions, but I'm going to remind you that this is a simple one. If I've got some function with its derivative or some constant times its derivative, then we need to remember that the formula sheet really should have the antiderivative of g dash of x over g of x is equal to, that's dx, is equal to log to the base e g of x plus c technically. So this is a very straightforward example of log to the base e, x squared minus 4x plus 5. I'm going to stop there and we'll do some more exam questions in the next video.